Okay, let's dive right into this explainer and take a hard look at a microscopic invader that has honestly probably made a victim out of every single one of us at some point. Yep, I'm talking about the norovirus. As an infectious disease expert, I actually spend my life studying how pathogens operate, and let me tell you, this particular virus, it is an absolute masterclass in biological warfare. So today, we're going to decode its playbook, understand exactly how it attacks our bodies, and most importantly, learn how we can actually defeat it. But first, to truly respect our enemy here, you need to grasp the staggering scale of this threat. Worldwide, norovirus causes an estimated 650 million cases of acute gastroenteritis every single year. Let that sink in. That includes about 200,000 cases in children, and tragically, it results in roughly 50,000 deaths, mostly in lower-income countries. And the financial toll? It's estimated to cost $60 billion globally in healthcare expenses and lost productivity. So yeah, this isn't just some minor inconvenience we're dealing with. It's a massive, massive public health burden.
Section 1. Meet the ultimate stomach bug.
Now, people often mislabel this as the stomach flu, but actually, norovirus has absolutely nothing to do with influenza, which is a respiratory illness. What it really causes is acute gastroenteritis, basically a really severe inflammation of your stomach and intestines. And its secret weapon? Well, it's the armor. Norovirus is what we in the field call a non-enveloped virus. So instead of having a fragile, easily destroyed lipid outer layer, it's protected by a super tough, rigid protein shell called a capsid. This biological armor makes it incredibly hardy. It's highly resistant to freezing, it can survive heat up to 140 degrees Fahrenheit, and it literally neutralizes some of our favorite modern disinfectants.
Section 2. The infiltration. How it spreads so fast.
So how exactly does this tiny villain spread so incredibly fast through places like restaurants, daycares, hospitals, and cruise ships? Well, it spreads rapidly through what we call the fecal-oral route. You can pick it up from direct contact, like if you're caring for a sick family member, or by eating contaminated food, or even just touching infected surfaces, we call those fomites, and then absent-mindedly touching your mouth. It can even become aerosolized when an infected person vomits, which is a pretty wild thought. But the main reason these outbreaks are so explosive is the infectious dose. It is terrifyingly small. It only takes fewer than 10 to 100 microscopic virus particles, or virions, to launch a full-scale attack on your gut. To put that into perspective for you, a single incident of vomiting can expel millions of these particles. Millions!
The timeline is really what makes these outbreaks so relentless and tough to stop. After you're exposed, the virus incubates for a mere 12 to 48 hours before those violent symptoms just hit you out of nowhere. Now, the active illness usually only lasts 1 to 3 days, but here is the catch, and this is crucial. Even after you feel totally better, you can continue shedding the virus and remain contagious for 2 weeks or more. And if that wasn't enough, if a room isn't properly cleaned, norovirus can survive in a dried state on hard surfaces for up to 28 days, just sitting there, patiently waiting for its next host.
Section 3. The attack. Norovirus versus food poisoning. When those intense symptoms do hit, a huge part of my job is figuring out the root cause. Because the symptoms overlap so much, telling the difference between a viral attack and bacterial food poisoning is absolutely critical for how we treat the patient. The real giveaways are the onset timing, the specific symptoms, and your exposure history. If you experience sudden, forceful vomiting and watery diarrhea that hits really quickly after you've been in a crowded place like a daycare or an office building, that heavily points to norovirus. But on the flip side, bacterial food poisoning usually has a more variable onset time. It might involve bloody diarrhea, it generally brings a much higher fever, and we can usually trace it back to a specific suspect meal, like an undercooked burger at a weekend picnic.
Section 4. Triage and recovery.
Okay, once we know it's norovirus, we have to move fast. And I need to be crystal clear about something right now. There are no antiviral pills for norovirus. None. And because it's a virus, throwing antibiotics at it is completely useless. They only fight bacteria. So recovery is all about strict triage and managing the biggest, potentially lethal danger here, which is dehydration. When your body is violently expelling fluids from both ends, dehydration escalates incredibly fast, especially in young kids, older adults, or anyone with a weakened immune system. You really need to watch for extreme thirst, dark yellow urine, dizziness when you stand up, or, and this is a big one, a baby crying with no tears. If you or someone you love shows these signs, especially confusion, lethargy, or if you can't keep any liquids down for 8 hours, things have escalated. You absolutely must seek medical care immediately. You might need IV fluids.
Now, for the vast majority of you who will just be managing this at home, you have to systematically reclaim your gut.
First things first, rest the stomach. Just slowly sip clear fluids, maybe 2 to 4 ounces every 15 minutes. Please, don't just chug a giant glass of water, you'll probably just bring it right back up. Use oral rehydration solutions, those ORS packets, to replace your vital electrolytes. Then, as your stomach starts to settle a bit, you can introduce the brat diet. That's bananas, rice, applesauce, and toast. They're super bland and easy to digest. But at the same time, you have to strictly avoid gut irritants. That means no caffeine, no alcohol, no heavy dairy, and skip the spicy or high-fiber foods until you're 100% recovered.
Section 5. Defense strategies that work.
All right, now that we know how to survive the attack, we really need to focus on containment. And we need to correct a massive, dangerous public health misconception that I see all the time. Honestly, even in healthcare settings. I need you to commit this to memory. Forget the alcohol-based hand sanitizer. Just forget it, because norovirus is a non-enveloped virus. Alcohol, no matter how high the percentage, is virtually useless against it. The alcohol just can't penetrate that tough protein capsid armor we talked about earlier. To actually defend yourself, you have to rely on good old-fashioned soap and water. The soap doesn't even necessarily kill the virus, but the physical friction of vigorously washing your hands for at least 20 seconds physically detaches the virus from your skin and flushes it straight down the drain.
When it comes to your environment, those gentle, everyday multi-surface cleaners, they aren't going to cut it. To truly decontaminate kitchens, hospital wards, or your own bathroom after an outbreak, you have to break out the strong, bleach-based disinfectants. Any contaminated laundry or blankets must be washed in hot water. We're talking at least 140 degrees Fahrenheit. And from a workplace policy standpoint, any symptomatic staff, especially if they work in food service or healthcare, they have to stay home from work until they've been completely symptom-free for at least 48 hours. And if you're the one sick at home, do everyone a favor and do not prepare food for anyone else for at least 3 days after you recover.
Section 6. The future counterattack.
So, hand washing and bleach are our best defenses right now. But historically, the biggest hurdle in defeating norovirus is that we don't have a vaccine. Why? Because the virus is notoriously difficult to grow and study in a lab using standard cultured cells. It just doesn't want to cooperate. But there's a brand new medical breakthrough that's literally changing the rules of engagement here. Researchers at the University of Osaka have pulled off something truly remarkable. They've developed a reverse genetics system using zebrafish embryos. By directly injecting synthetic norovirus DNA, called cDNA, into these tiny embryos, researchers can finally generate and study infectious, recombinant human noroviruses without even needing those cultured cells. This means scientists can now actually manipulate the virus, tag it with reporter genes to watch how it moves in real time, and finally understand exactly how it replicates. Because we can finally study this virus efficiently in the lab, we can actually begin developing targeted antivirals and, most importantly, vaccines with controlled antigenicity. It's a massive leap forward. And it leaves us with a pretty profound question to ponder as we wrap up. With this zebrafish embryo breakthrough paving the way, how much longer will the ultimate stomach bug hold humanity hostage? Will this new biomedical tool finally be the key to engineering a vaccine and closing the invader's playbook for good? Let's hope so. But until that day comes, keep washing those hands with soap and water and stay vigilant. Thanks so much for joining me today on This Explainer.